Hello everybody, I'm Alexey Kraborov, the organizer of Reactive Systems Meetup, and here on location at Nitro, and we have, for the first time in our meetup history, we have really amazing stack written in C++ from Lift Engineering, and we have Matt Klein with us, who is a software engineer at Lift. Welcome.
Thank you.
So can you tell us a little bit about what does Lift do with this software you guys work on, and how did it come about, and why is it so cool?
Sure, yeah. So we're talking about Envoy today, obviously. So Lyft runs many services. It's a pretty large service-oriented architecture. I think the current numbers that we're publishing are greater than 100 services. We do about 2 million requests per second internally. And it powers essentially all of our real-time systems. So whether that's locations ingestion or basically route finding or ETA or kind of all of that. So how Envoy came about is when I joined Lyft about 1.5 years ago. Lyft had pretty kind of normal service-oriented architecture. A bunch of services. We were entirely hosted in Amazon. We're using ELBs, a bunch of different kind of languages and random implementations of kind of different service call frameworks. And a lot of the problems that people typically have kind of when they're running service-oriented architectures. Random failures that people didn't know how to debug. People were generally kind of afraid of making service calls. Had a lot of conversations with folks about how they were going to put this thing in a library and like send it out to every service because they were too afraid to actually call other services. So that was kind of the situation when I joined. And fast forward to now, we have Envoy, which is this out-of-process proxy, and we use it for both egress and ingress for all service calls from every service. And the idea behind Envoy is that you have kind of a centralized piece of software. Well, it's not centralized. It's centralized in the sense that you have a lot of code written in one place, but it's fully distributed. And all requests go out kind of a local Envoy running next to every service, and they come into another Envoy. And Envoy handles essentially all of the common things that you need in service-oriented architecture. So things like load balancing and circuit breaking and rate limiting and kind of all of that good stuff. And most importantly, it allows us to get a really nice picture of what's going on in the system. So that's stats, logging, tracing. So how did this come about? I've been working on networking and distributed systems and operating systems for probably 10 or 15 years, and I've seen how a lot of companies do this. And we've kind of seen this progression over the years where a lot of the big companies who are lucky enough to use one language, they typically are not polyglot, they're typically using one language. They typically build up kind of this really nice library that does all of these things, but you're forced into using that language essentially. And unfortunately, with kind of a lot of the modern companies that tend to be more what we call polyglot, they tend to be using Java and Go and Python and PHP and Ruby and kind of all these things. It's very difficult to write a sophisticated library that can do all of these things in one place. So before Lyft, I was at Twitter. I wrote Twitter's front-end proxy, which is written in C++ 11. And that currently serves all of Twitter's site traffic. And I observed, obviously, and interacted a lot with Finagle, which is kind of the service-to-service library that Twitter uses. So Envoy, in many ways, is the result of kind of the observations of Twitter, and actually before Twitter, working in Amazon, I worked on networking in Amazon's EC2, and just kind of observing how people deal with some of these problems. And in some sense, Envoy is kind of a combination of multiple systems. I wouldn't say that there's any component of Envoy that is particularly novel, but I think the packaging, kind of how it's put together, is actually pretty novel. And it's been really exciting just to see kind of the demand. It's only been open source for kind of like 1.5 months. And I've just been really pleasantly surprised with people coming out of the woodwork who are pretty excited about
right? Like I've seen this on Twitter,
Right.
and like I grabbed it, right? Because
Right.
not every time. But the reason actually I got so much interested, now I understand that you've seen finagle, and in kind of our GVM centric little bubble, around big data and things like that. So I've seen basically how much finagle helps Twitter, and so now there's a company called Buoyant which basically took that and came up with Linkerd, right? Which is basically I found kind of the language they're using is very similar, right? And they're talking about proxy, and I find like this is actually a very interesting way to talk about it, because people previously, they talked about essentially HTTP, or they're talking Akka world, like actors, right? But so I wonder, what do you mean by proxy, right? And then you have L7, right? Can you talk a little bit about that?
Yeah, no, that's a great question. So kind of one of the design points of Envoy, and this is something that I learned from the system that I built at Twitter, is the proxy. And by proxy, I just mean kind of bump in the wire, right? It's a thing that's intercepting network traffic, and it's doing something.
Like a shape proxy.
Yeah. I mean, it might be doing just sniffing, meaning it might literally just be a bump in the wire, or it might be doing parsing and load balancing. So you have HA proxy as a proxy for TCP and HTTP traffic. Nutcracker as a proxy for Redis, right? I mean, you have all kinds of different proxies. But one of the mistakes I think that was made with the system that we built at Twitter, at least on the proxy side, is it was very HTTP specific. And what I've come to realize is that yes, most modern service calls are some form of HTTP, whether it's REST or now we have gRPC from Google, right? There's a bunch of different stuff going on. But obviously, modern architectures, they use a bunch of other stuff. They use caches, they use databases, and you end up having a lot of the same introspection and visibility problems with those things that you do with HTTP. So, and by that I mean, so at Lyft, for example, we're using MongoDB. And Envoy, we actually have a MongoDB sniffer that's built into Envoy that parses the MongoDB traffic as it's coming through and basically generates stats.
Interesting.
And we find that invaluable because now, again, when we access MongoDB from Go, PHP, and Python, we get unified stats, and we get rate limiting, and a bunch of other stuff that we've actually built in. So that was a long-winded way of kind of circling back. And at its core, Envoy is a network-level proxy, meaning it's kind of L3 and L4. And by that, I mean it's just bytes in, bytes out. And then there's kind of a pluggable filter mechanism, somewhat like what they actually have in Finagle. And then you can build kind of filters that do various things on top of that, whether it be Mongo or rate limiting or auth, and then obviously we have HTTP. And then on the HTTP stack, we have a second layer of filtering. And that allows us to do HTTP level things just because that's so common. But at its core, the idea behind Envoy is that it's a byte level proxy that we can use to intercept all traffic. And I think Envoy is most useful when the applications are essentially in a network jail. And by that I mean the application can only egress, go out through Envoy, and can only get traffic coming in through Envoy. And that gives you this thing, theoretically, that you can trust, that's generating, again, logging, stats, tracing, all kinds of value-added features that are at every hop. And it allows the application owners to focus on business logic, and we put a lot of that plumbing kind of at that base layer.
Right, so basically when I say, byte level, so basically you can intercept all the bytes, and if somebody bothered to parse them and understand them, right, then you can do something about it.
Exactly. So out of the box, Envoy can actually just be kind of an SSL proxy replacement. So you can basically have a TCP proxy and then just do SSL termination on both sides, and it can have that basic function. But then with the filter framework, you could, for example, do rate limiting, or you could do auth, or you could essentially compose a bunch of other things also.
Nice. And obviously another interesting thing for us is C++.
Yep, sure.
And so we used to see obviously a bunch of Java and Scala, and then recently we see kind of DevOps side gives rise to Go. Like basically, like Go is kind of doing Docker, and then suddenly it's doing a bunch of other things, and kind of I think we've seen this also in kind of functional programming world where Scala kind of is the most widespread. I noticed that when people want to do systems, they often try Rust, because that's another thing which is kind of built as functional, but then there is a lot of blog posts saying, I tried Rust as a functional programmer, and then I had a lot of tears, and the best way to do it, not to treat it as a functional programming language, right? And so I'm just curious, right? I mean, I personally didn't touch C++ in a while, right? So why C++? What is your impression? How do you compare it with Go and Rust as kind of other systems languages?
Yeah. So I guess for starters, for full transparency, I tend to be a pretty boring engineer. I like tried and true, right? So for kind of a fundamental systems component like Envoy, when we were choosing a language, I wanted an ecosystem that was already pretty robust, right? So that means, good debuggers, good profilers, very robust libraries, stuff like that. So to be honest, Rust wasn't really on the table, just because I don't really consider that, at least at its current state, to be kind of production ready. One of the things that I like to educate people on is I think a lot of people, the last time they looked at C++ was when they were in college, which is 10 or 15 years ago. And C++ 11, which was kind of fully ratified, obviously, 4 or 5 years ago and is in pretty much every compiler now, is honestly an absolutely awesome language. And if you haven't looked at it, I would really encourage you to. And even from a functional perspective, you would be surprised to know that C++ 11 actually has, in my opinion, one of the best Lambda implementations. Has capturing. It's very explicit about how it works. I think it's actually fantastic. I personally, I don't consider myself a functional programmer, but I do think that there are some great things from those functional paradigms that have actually made their way into modern C++. So, I think C++ 11, in my opinion, is almost a perfect blend of kind of some of these paradigms. So I would really encourage anyone that wants to kind of look at a high performance kind of language with a great ecosystem to actually look at C++ 11.
Can you guys do MapReduce in C++?
I'm not a MapReduce person. I'm sure you can. I couldn't tell you off the top of my head how one would go and do that.
Well, the typically kind of, in kind of reality, at least, I've seen, functional programming very often just tends to be, you basically work with the whole collection as opposed to kind of individual elements, and then you have some kind of a map or reduce or fold, and then basically all you use is basically MapReduce and Lambda, right? And I mean, people in C++ are not used to write like this, but if the tools are there,
I mean, there are definitely libraries out there that do most of these things. Like I was saying, for me personally, there's some functional aspects, whether they be lambdas or other things that I think are really great, and we actually use those in the Envoy code a lot. The style of the Envoy codes tends to be a little more imperative, but
I think that's the nature of networking, right?
Right.
People use C and C++ for networking since the beginning, and I guess the other nature is probably that you do not really see big data because you have packets coming in, right? What do you do about streaming? Like, for instance, let's say, do you give many primitives to interpret 10 packets as a window and do something with them? Like, let's say there is streaming is all the rage these days, right? So can I do something like streaming processing?
Sure. Yeah. So Envoy was built from the get-go to be fully streaming. So meaning, and by streaming, it has built-in capabilities to do buffering, because you often want to buffer a portion of things if you're looking at, for example, headers or kind of other things. But Envoy, in the filtering framework, has the capability of both full streaming and also buffering and then essentially restarting. So we, at least from the programming perspective, we try to give people the ability to kind of do both things, whatever actually works for them. But yeah, so Envoy at the kind of the TCP, at the byte in, byte out layer has built to be streaming, and also at the HTTP layer, it's built to be streaming also, or buffering.
Cool. I want to follow up a little bit about the C++ choice as it reflects in hiring.
Sure.
Right. So because I think the kind of the kind of the state of C++ market was that people, tend to be with really good C++ skills, tend to be very senior, and kind of Wall Street, vacuums them out, right? So you have like high performance computing essentially,
Yep.
right? So what do you find when you kind of were hiring people to work on this project? I'm just curious, like how is basically hiring for C++ in this context? Is it easy? Is it hard? What kind of people are interested in working on these problems?
Yeah, that's a very interesting question, and I think with C++ in particular, for better or worse, there tends to be a lot of FUD kind of around C++, right? That it's this very scary thing that like only these crazy arcane people actually know how to do it, and it is true that if you were to try to start working on C++ without proper mentorship, it would be very difficult. Though I would argue that we work in an industry that is mostly apprentice-based, and that people learn how to be programmers by working with other programmers.
Yes, mostly everything.
Right. So if you look at my current team, I have 3 people working with me now, and I think 2 of them had done C and C++ prior to actually joining, and one of them is actually straight out of college. And to be honest, I think C++ can be taught like any other language. So with the right kind of apprentice-based setup, I don't really think it's any hard or less hard to hire for C++. I think it's just you want to hire quality engineers. And if an engineer is interested and is not afraid of C++, because I think honestly of some of that FUD, I think they can be taught. So I don't view it as any different, really.
Nice. And also I think the fact that you guys are in Seattle and you have Microsoft next door, which is using a bunch of C++, and Amazon, and Google.
Right. So I mean, if you look like Microsoft, Google, I mean, really at this point, Facebook, I mean, any large company at scale is using a lot of C++ still. I don't keep track of the kind of the language rankings, but I mean, C and C++, even though we have a lot of people talking about a lot of other languages, C and C++ are still very popular languages.
Yes.
So,
which reminds me, I think I've seen a book about modern C, not C++, and it was called something about this is not your father's C, right? Like we have debuggers now, we have all this stuff.
Oh yeah. And that's I think what again people don't realize is that particularly with C++, with modern C++. I honestly cannot remember the last time that we had a memory leak in production, right? And that's just one example. And what I find funny is that there have been so many times when I've been working with people who are writing systems on JVM or kind of other systems, and once a year or twice a year, there's actually a memory leak in someone's JVM project because of some complex cyclical dependency, right? And it's actually with modern tooling and kind of modern, I would say, language guidelines in C++, it's very difficult to actually have a memory leak, right? So it's just kind of one of those things that I've always found very ironic, and it kind of leads me back to some of that, I think, FUD just about C++, where I think there's this kind of like ethos, or people view it as this scary thing. But I would just encourage everyone out there that's watching to take a look at modern C and C++ because it's really fast. The tooling is fantastic. The developer productivity, I think, is great. So
now I'm thinking that you should come back and give this talk to us.
I would.
Modern C++ and modern C.
I would love to come back and do a separate talk just on C++.
Yeah, because
I'm going to talk about it tonight, but I'm going to spend like 2 minutes talking about C++.
Just out of curiosity, like what kind of IDEs people are using? Like VI and the Max, or like are they using IntelliJ?
It's pretty varied now. Probably, obviously, there's a lot of people using Vim and Emacs.
And Visual Studio is now cross-platform.
Visual Studio is cross-platform. A lot of people now are using the IntelliJ product. It's the C Lion. So people who are generally familiar with doing all of that, with their IntelliJ or other things are kind of using that.
That's easy.
I use an editor called Slick Edit, which everyone at work makes fun of me for. It's this thing that's been around for 20 or 25 years, but I've used it for 10 or 15 years, and I love it, so I just keep using it.
Well, that works. But IntelliJ is fun, right? Because that's number one kind of Scala and Java thing, right? And then, of course, it has versions for like Ruby and PHP.
Well, but that's also part of it, is that C and C++ have just been around for so long that even whether it's Vim or Emacs or the other editors, like all the tooling around it is quite good.
Yeah.
I mean, and people are always surprised when I tell them, yeah, you can do autocomplete in C++, and people are shocked. No, it's not crazy.
Right. Well, I'm not actually curious. I'm gonna poke around, Envoy, it's open source, right?
Yeah,
I'm gonna check it out. So, well, I think we got a really good picture. So we're looking forward to your main talk, and we'll be happy to have you back at our meetup anytime to talk about modern C++.
Great, thank you very much.
Thanks, Matt.
All right,
Appreciate it.
yeah.